and thank you for tuning into the Light It Up podcast. On today's episode, Tom sits down with Paul Gosselin to talk everything landscape lighting. Paul is the owner of NightScenes Landscape Lighting, located in Austin, Texas. Some of you may also know Paul from his published book, The Landscape Lighting Guide. I'll let Tom pick it up from here.
Well, Paul, I'd like to thank you to the Light It Up podcast. I appreciate you taking the time and coming on this podcast. The Light It Up podcast is a neutral-based podcast. We typically don't highlight any advertisers or anything like that. It's all about education and helping people in this crazy lighting industry learn as much as they possibly can about lighting, LEDs. If they have any questions, we ask them to send us an email, and we'll do our best to answer those questions. So about Paul, you're the owner of NightScenes, a landscape lighting company near Austin, Texas. Welcome, and can you tell us something about yourself?
Well, thanks for having me on, Tom. I really appreciate you asking me to be here. A little bit about myself. Well, I'm actually located about 40 miles or so northwest of Austin in the beautiful Texas Hill Country, what we call the Highland Lakes area. A little bit about myself. Let's see, I'm married to my lovely wife, Patty, for almost 23 years. I've got 3 kids ranging from 41 to 29, and 4 grandchildren from 18 to 12. Oh, wow. So well-rounded in that way. Got into outdoor lighting in 2004, started NightScenes in March of 2004, so 16 years ago. And before that, I was an electrician, and that's kind of how I got into lighting, was from the electrical side. I had a little electrical business and discovered that lighting is so much more fun than climbing in attics and doing electrical work.
Especially in Texas in the middle of summer or anything like that. But that was my next question. If you were in the lighting industry prior, and if you had any experience in the lighting industry before getting into landscape. So you were an electrician. What kind of geared you towards landscape lighting? Did you install some landscape jobs or what?
Well, no, it actually just fell in my lap. I had a client who had a little area where he and his wife liked to hang out in the evening. He kind of created this nice little water feature, and he asked me one day if I could do anything there to kind of make it a little bit nicer in the evenings, because it's about the only time we get to enjoy our outdoors here in the summertime. and so I took a look at it, and I said, sure, yeah, I'll come up with something. And I went to the local big box store, bought a bunch of stuff, because, electricians don't know about low voltage landscape lighting. So I went and I bought some stuff and went and looked at it that night with my family and just fell in love with it, and decided after that weekend that this is where we were going to go. We weren't going to be in an electrical business anymore. We were going to go into the outdoor lighting business.
Right. Well, that's great. And people spend so much money on landscaping their house, and it always looks beautiful during the day, but it looks a heck of a lot more beautiful at night, especially if it's lit up and if it's lit up well. So I understand that several years ago that you wrote a book on landscape lighting. What's the name of the book?
Well, the book is The Landscape Lighting Guide. It's a Contractors Resource, and it's on Amazon.com. Published it in July of 2017. So it's almost 3 years old now, almost time for a volume 2, because lighting has changed in lightning speed over the last few years. So it's probably about time to start looking at a rerun.
Right. So what inspired you to write a book on landscape lighting?
Well, the thing is that I have a blog on my website, and the blog has about 200 different blog topics. And I get emails all the time from people all over the world asking me about outdoor lighting. They're asking me questions. And one day somebody asked me, well, why don't you just write a book? And I was like, ding, yeah, why not? So I had so much content already, had to rewrite some of it because my blog is really geared toward the homeowner. So I had to kind of write some stuff differently to start targeting the contractor and such. So that was the inspiration behind it. It's just somebody saying, well, you got all this content. Why don't you write a book? And so there you go.
No, that's great. So if there's one takeaway from the book, what would you say that it would be?
That it is a guide. It's a guide for people who are just wanting to get into the outdoor lighting business. It's really not something for the seasoned pro. Okay. Yeah, they might get a few things out of it. But really it's for the novice, the guy who, retired firefighter or a landscaper or somebody like that who wants to get into outdoor lighting. It gives all the essentials, what it doesn't do is teach somebody lighting design, because personally, I feel that the only way you can really learn design is to get out there and do it. Because there's no way I can describe to somebody the difference between one fixture and two fixtures on a crepe myrtle, or the difference between 2,700 degrees Kelvin and 3,000 degrees Kelvin, or a 35-degree beam and a 60-degree beam. The only way you can know what those effects are going to be is to get out there and actually do it.
Sure.
So what I don't want people to do is think this is going to be a know-all, be-all book, because it's not. It's here's how you get started, the very basics of business. Here's all the tools of the trade. Here's, voltage drop calculations, some technical stuff like that, some very basic design concepts and, stuff like that. And the rest, you got to get out there in the field and do it.
Yeah. One thing about landscape lighting, it's a part science, part engineering, it's a part art. And it's really a practice, It doesn't seem like you ever get it 100% until you do all the different tweakings, and no 2 yards are the same or anything like that. So, you're absolutely right. It's a real challenge, and people are learning by it all the time. So one of the main points that I wanted to discuss today was drop-in retrofit lamps versus integrated fixtures in landscape lighting. What's your split on integrated versus drop-in or retrofit lighting?
I would say I'm probably about a 70-30 split, 70% integrated, 30% drop-in. I am seeing that I'm getting more drop-in, depending on the clientele. Sometimes you have to make some compromises, and I'll go, well, how can we cut this back a little bit? And I'll go, well, we can do this. I almost always use drop-ins when I'm doing downlighting, because I want the versatility of a drop-in fixture. I would say about 70-30.
I see. And I think you're a little bit, don't take this the wrong way, but heavier on the integrated side versus a lot of people that I've talked to in the past. A lot of people have been about 50-50 and more leaning towards drop-in than integrated. So it's good that I'm talking about this, because I like to learn more and more about why people do what and all of that. So why do you use one technology over another on a particular job?
Primarily, the reason is the lifespan of the product, right? The best LED drop-in that I'm aware of is about 25,000 hours. Where integrated, you can get a lot of them are 50,000 hours, and that's all. That's, to me, that's still guesstimating, but it's twice the lamp life, basically. Now, the cost difference is what it is. What I generally try to do is, if I'm doing demos, which is getting off the topic a little bit, but demoing with lamped products, right? So you can tweak it and find out exactly what you need, and then install the integrated product, that's going to have 10, 15-year warranty on it, as opposed to a lamped product.
Yeah, I completely understand. From an integrated standpoint, talking about serviceability, is there anything that can be done from a preventative maintenance standpoint to make a integrated fixture last longer?
Preventative maintenance. The only thing I can really say about that is make sure you pay attention to the technical aspect of the installation. As far as just regular maintenance, what can you do? I don't know of any regular maintenance, but if you're not paying attention to the voltage at the fixture when you're installing it, and paying attention to those technical aspects on the front end, I have found where integrated products can prematurely fail because they've been either undervolted or overvolted. Because people were just, they just hook them up and then, hey, you can put as many lights on a wire as you want, that
right.
kind of attitude. And don't think that, that you have to worry about things like voltage drop and such. And we run into situations on a regular basis where integrated product, and lamp product for that matter, has failed due to people not paying attention to the voltage.
Huh. What, on the integrated product that you use, what is the voltage range?
Usually printed on their documentation, it's usually somewhere between 9 and 18 volts, depending.
Okay.
I know of product that, you can go a little lower and a little higher. But that's usually what's on their paperwork.
Sure. And on integrated product, is it typically dimmable or not?
Some of it is, and some of it isn't, which is something also that has to be taken into account. In situations that I work in, I generally try to dissuade clientele from trying to dim LED, because some of it you can dim the transformer, some of it you can dim it on the secondary side. I'm not a fan of dimming transformers.
Right.
If it's designed properly, you don't have a need to dim it anyway.
Sure.
Because it's designed right. If anything, you need to crank it up a little bit as the landscape matures. But dimming generally isn't a situation that we get into.
Yeah, the only reason I can see for dimming would be more seasonal. For the summer months when a tree is fully foliated or something like that, you might need to crank it up when it loses all of its leaves, dim it down. But that's real individual.
Yeah. And that might be more regional. Here where I am in Central Texas, most of our stuff is evergreen. It's live oak trees and cedars and stuff. So most of our trees stay green year round. So it might be something that, it might be a regional thing to be, to have that functionality to be able to dim things. I can see where that could happen, especially in snow.
Right. Yeah. If your trees lose its leaves, it's got bigger problems, right?
Yeah. But we do have elms and such, but usually those are so big that you're going to want the punch anyway. So,
sure.
So it's not an issue.
Of the products that you sell and install, if something goes out, is there any way to troubleshoot or replace a board or a driver or something like that?
On the integrated products that I use mostly, the answer to that question is no. There are some that I use that that you do that with, you can replace a driver. Um, but the vast majority of what I use, I can't replace any parts. It's replace the fixture. And I've found, and this is just, what I've found in our area, the fixtures that you can get into to fix are usually the fixtures that have corrosion in them on boards and stuff like that. And we generally talk our clients into replacing them.
Sure. From an environmental standpoint, are integrated any more or less susceptible to those types of failures?
Once again, depending on the product. Golly, I don't know if they're any more susceptible really than a lamp, to be quite honest. Lamps are usually really well sealed and potted, but then again, I have found lamps that I've used over the years that, oh golly, it was, back in the day when lamps were just starting out, there were a lot of problems. But now I think things are kind of evening out.
Right. I think I was getting at, listen, best case scenario, you're using a UL fixture. It's a fixture for wet location, meaning that water cannot get on the inside. But listen, if it's sitting in if it's raining and the thing is sitting in a foot of water, it's possible that water can get inside because a foot of water isn't included on UL's rain test.
Right.
So, I don't know if the integrated fixtures, if the boards have conformal coatings on them, if they're more or less susceptible to corrosion versus the bulbs. I don't know. I was just asking.
Well, I guess, on the fixtures that I can't get into. Okay, so they're completely sealed and potted fixture. You can't get into it to work on it anyway. Right. I have had them actually go through floods. We had a situation around here not too long ago where we had, the fixtures were under, I think at one point like 8 feet of water. And we had to dig them out. We had to dig out over a foot of mud underneath them, or that had covered them up, and they were still working. Okay. So I would say as long as it's a really well sealed and potted fixture, water shouldn't be able to get into it, and that shouldn't be a problem. I have seen other fixtures that you can get into to repair, okay, or replace a board or whatever. Inevitably, if I can get into it, water can get into it. And, somehow, humidity or what have you is going to get into there, whether it's wicking through the bottom or through the gaskets or whatever the case may be. Mm-hmm. And I've taken pictures of some of these boards that you can see the corrosion on, and so in those situations, I've found problems. So I hope that answers your question.
Yeah, no, it does. Have you ever had problems with interference of garage door openers or gates or television?
Back about 10 years ago when LEDs were really coming on strong in the industry, there were a lot of problems with that. And I still hear of it every now and then. We make sure that we don't purchase anything that's not FCC compliant. Okay. So that's pretty much eliminated that situation for us. But I still hear tell of it happening out there in the industry. So I guess some people are still using some products that are not FCC compliant.
Yeah. It's usually you'll find it on the less expensive fixtures or bulbs that, if it doesn't meet FCC, the coil or the other components that goes inside, it's very inexpensive, costs that manufacturing cost is $1 or so. But I mean, there's nothing more frustrated than pulling up to your garage at night. Then you can't figure it out. You go, oh, honey, last night my garage door opener wouldn't come down. Wouldn't come up. In the morning, everything's working fine. What the heck's going on? I got to replace the garage door opener,
Yeah.
So, but it's all that.
It's somebody saving $1 on a fixture or a lamp,
Yeah.
And,
yeah. That's pretty nuts.
Or it's just ignorance of the issue. Not saying stupidity, saying ignorance, just not knowing about, the situation with FCC compliant lamps. Because some people just, if they're not educated on it, they don't even know the situation exists,
No, sure. No, I get it. So what about, on these, like, call them accent lights or up lights or whatever, single versus multiple beam technology? What are you seeing?
Wow. Well, that's come a long way. I'm really a fan of the Cobb, the chip on board single emitter. There are products out there that have multiple emitters, and what I've noticed is, generally speaking, in my opinion, I wouldn't want to use multiple emitters on a flat surface, like on the facade of a house or something.
Right.
I think they're fine to light up vegetation because you're not going to see the striations and stuff. But I wouldn't use them on a flat surface, especially if that surface is light colored, because you do see, that the different beams coming on that thing, and so it to me it just kind of looks weird. There have been, like I said, there's since LED has evolved so much, I'm seeing more people go to the chip on board technology.
Right. And so even with the integrated, you seeing that as well?
Oh yeah, absolutely. Probably even more with integrated, seeing the striations and stuff with the integrated as opposed to a single chip lamp. The effect on a surface can be pretty dramatic.
Right. Yeah. And like you said, even on an architectural element, it's even more dramatic than that.
Oh yeah.
Have you ever messed around with DC current, DC transformers or anything like that?
I have a little. I like the idea of it. Just the idea of direct current, not having to worry about voltage drop as much. Being able to, have putting more fixtures because you don't have the VA to worry about with DC. I don't know if it's really going to take hold in the United States as much as it might, in Europe where they use, 240 volt and stuff like that all the time. But I've used it. I worry about people using it who don't understand DC over AC and do things, have problems with, crossing their polarity and stuff like that in DC situations. So, yeah, I've used it. I don't know that it would be something that I would favor, at least not at this time.
Right. And I'm just curious if, all integrated and drop-in would work with DC, or the performance would be the same.
Wouldn't since LEDs all use DC power anyway, that's the driver is doing, at least the way I understand it, is converting it from AC to DC. I would think that so far all of the LEDs I've tried on DC have worked.
Mm-hmm.
Now, whether they'll work consistently
long term.
Whether they'd work long term would be the thing. But I would think that they would favor DC power to AC power. But then again, I'm not an electrical engineer, so.
Did you get the power supply that you were using? Was it magnetic or electronic?
I mostly use magnetic transformers. Used
for the DC ones that you were playing around with. Were those DC as well?
Well, those were DC transformers.
Okay.
I've used DC transformers, and I think there's a new system out there that runs pretty much all on DC.
Right.
So,
yeah, it was funny. It probably goes back 6 or 7 years ago. I was actually in Hong Kong at a lighting party and met this guy from Australia who was a landscape lighting. He sold the product and he also installed it. And he was telling me about all the benefits with, the longer runs and this and that, and not have to worry about some of these other things. And he says, but there's one thing that you have to take care with. And he says, if you don't make a good watertight connection, the corrosion will kill you.
Yeah.
He says that your splice, your connection, whatever, has got to be as rock solid as possible. And he says, just look at the battery terminals, on your car. He says, if you don't take care of them, if you don't grease them, you don't maintain them, they're going to corrode like crazy. He says the same thing about the current on the landscape lighting run. So, but that was interesting. It'll be, some of these guys out there with different potting solutions for the electrical connections or the shrink wrap or whatever. Are those good enough for this type of connection? I'm sure we'd have to do a lot more investigation to find out.
Yeah, probably use some kind of anti-oxidation material on your connections,
right?
Just to keep that from happening. But that makes sense. I can see where that could be a problem.
Yeah, put a grease pot within a grease pot or something like that.
Yeah.
You ever taken consideration inrush current when loading up a system?
I think we used to see situations like that even with LED or even before LED. Matter of fact, before LED, I think I saw even more problems with it, especially when it came to a certain brand of electrical panels. They'd have let's see, is that QO brand? Golly, I'm trying to remember the Square D. Square D QO brand electrical system used to, if your transformer was too close to the panel, it would trip the breaker when it came on. And it was because of the inrush current, especially on bigger transformers. I haven't seen that problem since LED. So I can't really personally speak on whether it's a problem now for others, but we haven't seen that problem in a long time.
Right. So I'm going to kind of quiz you here. How close do you stay to the 80-20 rule as far as loading up a transformer?
We don't go over 70%. we do 70-30. I want to have more room.
That's probably why you're not seeing an inrush issue. Several episodes back, I think it actually was in our second one, we took a trip to Chicago and met with the owners of LTF Technology, who produce a vast variety of electronic transformers, drivers, and all of that. In my opinion, one of the best in the industry. And they also produce some magnetic landscape transformers and all that. And we were talking a little bit about inrush. That's just like, inrush current exists. It exists on LED bulbs, and it doesn't matter, on this power supply or that power supply. inrush current is it's there. What's interesting about all of this is some of my other conversations with my buddies in the industry, and we're talking about, do you think inrush current needs to be an actual rating so that you know how much you can or can't load up? For instance, take one person's MR16 7-watt bulb, and it might have a very, very low inrush of like 4.2, let's just say. And then you take another person's similar wattage bulb, and it's like double that. I mean, it's all in the components. It's all in the circuitry, how things are designed. And, asking the owners at LTF, I says, what's going to happen if somebody overloads it? And they says, over time, you'll wind up breaking down the transformer, either electronic or magnetic. That initial surge is going to start, to impact the overall performance after a period of time. And yes, eventually, things can fail. Probably not so much on a magnetic system as on a electronic system, which would be a lot more immediate of a problem because all of the voltages and everything are all done by electronic components and all that versus, the magnetic coils. So it's just an interesting discussion to see where this is all going to go. And if people really take that into consideration. So there is a difference in the quality of the bulbs. I'm not sure about the integrated fixtures. I'm sure there's a quality based on the components that they use and all of that. I'm sure certain manufacturers produce more inrush than others. And, the goal here is that it produces zero inrush. That would be the best situation, the best feature where all of the power supplies then would pass. But, it is an issue. The people that don't play by the rules and go over the 80-20 rule, they go close to 100% loading, they're going to notice a bigger problem first.
I see where you're going with that. And I would think, the more information, the better. I always look at, whenever I pick up a product, it's like I read that whole label. I don't want to know every bit of that information. I want to know what the DA is. I want to know everything. So I would say, if there was an inrush rating, that would be fantastic. I only install a minimum 300-watt transformer anyway. I mean, if I'm installing 25-watt system, I'm putting in a 300-watt transformer.
Sure.
So that's probably why I just don't see the situation, the inrush situation. But I will definitely be keeping an eye out for it.
I think as LEDs become more and more prevalent in the industry and people doing a lot of different things with them and all of that, it's going to be something that we will certainly talk at with the American Lighting Association at Underwriters Laboratory when we review the landscape lighting standards and even some of the regular fixture and portable lamp standards. We'll talk more and more about inrush current. It is there. It is having some effect on parts of your system one way or the other. I think there's just not been enough testing and all of that done to see what exactly it does after a period of time. So,
yeah, it'll what gets me is LED is so new for so many of us in this industry, that we're installing incandescent and halogen lighting not that long ago. And learning to be far more in depth in troubleshooting and trying to figure out what's going on with these electronics that we just didn't have to mess with before. I mean, a bulb burned out before, you could see it literally, and replace it, and boom, done. Now, you have these intricate, circuit boards that you're having to deal with, and everything that goes along with that. I find it harder to troubleshoot a system now than it used to be.
Right.
But yeah, as it evolves, we'll get better at it, I think. And and I think the standards are gonna move pretty quickly, taking all those things into consideration.
Right. There was something I just got into, I think this last week or a week ago, and there was a custom dimmer manufacturer, and I believe that they were out of New York or something. And they were trying to make the old retro looking switches, and then they converted them into dimmers and all of that. And I think they had an inrush rating of it's like 500 amps for 2 milliseconds or something like that. So it was like, so what happens if you go over this? It's just, we need to dig a little bit deeper to make sure that, we're not going to have any problems with the system, 6 months or a year down the road. So,
yeah, 2 milliseconds. I mean, that's pretty short. I mean, it takes 6 milliseconds to be electrocuted, but like with a 9-volt battery in an open wound. So 2 milliseconds, that's super fast.
Yeah, no doubt. So let's talk about another crazy thing. Do you think there's anything that any individual or a landscape lighting company can do to mitigate transient voltage, like lightning strikes in the landscape lighting system?
Ooh, wow. Well, one thing I've learned is that you can't beat Mother Nature. We've lost entire lighting systems to lightning strikes, and it's trying to understand how lightning works. Somebody explained it to me once that it's basically like there's these veins in when lightning strikes a tree or the ground or whatever, it just spreads out, and it travels through the ground. And we had a personal situation where, lightning struck a tree. We didn't even have any lighting in or around that tree. And it took out our whole lighting system because it did find a fixture, or it went through the electrical system or whatever, fried every fixture, fried the transformers, fried the guy's home automation system and his AV system and all of that. And until we can, I think, better get a better grip on how we can at least try to mitigate it a little bit. A lot of products now have suppression built in, or they sell suppression that you can put on a system. But when you're talking about millions of volts of electricity, I don't know if there's anything we can do about it. But I'm sure interested in anything that comes about.
Right. Yeah, there's a couple of guys out there that sell voltage suppressors and all of that, and they say that they're good up to so many joules or whatever. It's just like, well, who wants to be around and measure those things? And
yeah.
Anyway. So regarding lightning strikes, when you have a fixture planted in the ground, do you think that plastics stakes or spikes are doing any better of a job protecting that fixture? There's guys out there that are still providing like solid brass ones because of the corrosion issues or whatever. You think the plastic ones are doing any benefit versus the metallic ones?
No, no, because I mean, most of the fixtures we use are have plastic stakes. Sometimes they have metal threads. We've used some stakes like that. I've used metal stakes. I mean, unless it's deep enough, I mean, it's not going to create a good enough ground anyway. And you got to drive a ground rod, at least 36 inches into the ground to ground it, right? For an electrical system. So I don't see how an 8-inch stake or a 10-inch stake is really going to do the trick anyway.
Yeah.
Especially when you're talking about lightning. Okay. I mean, we're talking about the strongest force that's ever been on the planet, as lightning. I just don't see, where an 8-inch metal stake is going to have any difference than an 8-inch plastic stake. Plastic stake might melt maybe.
And the failure with landscape lighting due to lightning strikes, what percentage of them is actually the lightning hitting the fixture itself or getting through the back door and hitting the wire and traveling up and blowing it up that way?
I think it's more the latter, the lightning coming in the back door than it is hitting the fixture itself. We've had a couple of times where we've had downlights in trees that have been hit by lightning. They just blow that fixture up. I mean, we found parts of it, a long ways away, where we've had direct strikes, right? And then, of course, then it travels down the wire, and trips the GFI in that. But the other situation I talked to you about just a moment ago, that lightning didn't hit any of our fixtures, took out the whole system. So I think it's definitely coming in the back door is far more serious than hitting a fixture.
Right. One thing that's been kicked around a little bit, I said that I sit on a lot of these standards committee panels with the laboratory, and one of the ones was 1838, the landscape standard. And one of the things that we've kicked around back and forth is, all of the transformers, they have I think it's a 20 amp circuit breaker on them. But we talk about in the landscape industry, people using 18 gauge, 14 gauge, 16 gauge wire.
Yeah. It's kind of a pet.
You see where I'm going with this thing, but if you got a 20 amp breaker, a 20 amp breaker on your panel on your house requires 12 gauge wire. Well, it doesn't matter if it's on the panel on your house or low voltage, amps are amps. And so, somebody puts a 14 gauge wire on a 20 amp circuit. I've seen fires started and mulch because, the wires melts the insulation and all of that. What's your take on all of that?
That's kind of like a pet peeve of mine. I've heard of the same thing, and it's something I harp on all the time, is you have to size the wire to the protection. Okay. Protection is a 25 amp circuit breaker. You have to have wire that's rated for 25 amps. In this situation, it's 12 gauge wire. You have to use 12 gauge wire. Now, unless you're using a 100 watt transformer, okay, 100 watt transformer is going to have probably a 8 or a 10 amp circuit breaker in it, not a 25. So you have to size the wire to that circuit breaker. Whatever that circuit breaker is rated for, that's the wire you have to use. And there's no ifs, ands, or buts about it. That's just the way it is. Because like you said, that coating on that wire will melt before that circuit breaker trips, because that circuit breaker is doing what it's meant to do, protect 25 amps. So if you're in there with 18 gauge wire on 25 amps, that wire is going to catch mulch on fire. It's going to burn down, landscapes and houses and all kinds of stuff. So
one thing that people don't realize is if you take like a 14 gauge wire and go hook it up to your transformer and go 50, 75 feet out and cross the wires, how long do you think it's going to take for that circuit to pop?
Right.
It's going to take a little while. It's not like 120 volts. If you take 120 volts and go 15 or 50 or 75 feet out and cross the two wires, that thing's going to pop immediately. So the resistance, it takes a little bit of time. And the time factor, I believe, is enough to heat up the wire, melt the wire, and if you have consumable materials around that connection, that you could have a potential problem. So.
Absolutely. And I think this is one of the biggest dangers in our industry right now. Is people go, well, I've only got 100 watts on this thing, or I've only got, in this situation, I've got 25 watts on this wire. Why can't I just run, 16 gauge wire? Well, it's because you're hooking it up to a 300 watt transformer, and it's got a 25 amp circuit breaker on it. You have to run 12 gauge wire, because somebody's going to add some more lights onto that thing. You might have put only 25 watts on it, but, somebody else could come in there, add 5 more fixtures. They doubled the load. There's just so many different things that could go wrong with that situation, and, well, I didn't do it. Well, yeah, right. You didn't do it, but you did put the wrong size wire on that circuit breaker.
Right.
So
right.
It is up to you, as the person installing it, designing the system. So, yeah, that's something that just drives me absolutely crazy.
So what do you think overall is some of the biggest, beginner mistakes or anything like that about laying out a landscape lighting job?
Technically or design-wise?
No, technically,
Technically, I would say that's it, and not actually taking the time to figure in wire size and loads and voltage drop. Which are the 3 big technical issues that you have to deal with when you're engineering an outdoor lighting system. All of those things are very, very important. And if you don't do those things, you're going to have problems, and almost guarantee it. And I would add one more thing: documentation. People don't document anything. When we install a system, we take amp readings on every line. We take voltage readings at every fixture, and we document all of it. We document our amp load on the primary side as well as the secondary side. And that way, when we go back in there and we have to troubleshoot something, or we're doing maintenance, we can go in there with a voltmeter, amp meter, and we can troubleshoot a system within a minute. We can find out what run it's on. If there's a problem, we can find out what run it's on. We can find out all kinds of things just because we have the documentation right there, and we can boom, nail it.
What's the biggest failure point?
Biggest failure point that we've seen is connections. Which is that's just super basic stuff. But we still see it all the time. People using like regular household wire nuts, or just twisting wires together and using electrical tape, which I just don't get, but I see it all the time. And so of course that's the biggest failures we see. And once again, people not paying attention to voltage drop and undervolting things. And then we have to tell the client, yeah, I know you bought this fixture or this lamp that's supposed to last you this many years, and it would have if this, right. If it hadn't been undervolted, or whatever, which is usually the problem. We'll find, we check voltage at a fixture and they're getting like 6 volts, 4 volts, and you go, what were you thinking,
Sure. Yeah.
So,
what is your favorite splice, mechanism?
Splice mechanism is, well, if we're talking about splices, I like using butt splices and heat shrink. If we're talking about connectors, Now, I tell people this is very regional. Okay. If I am in the Northeast or the Northwest where it's rainy and wet all the time and everything else, I'm probably going to go with, I'm probably going to use butt splices and heat shrink for everything, right? Because I want something serious. Or I'm going to use a Buchanan crimp, with a grease tube connection.
Right.
But where I am here in Central Texas, we have a very mild climate. Everything's pretty easy. I use dry-con connectors. And to be quite honest, I've never had a failure. And I think that would work with almost any kind of connection if people actually paid attention to the instructions on the connector and did it the way it's supposed to be done. We go through, whenever we hire anybody, we go through a class. Okay, this is how you make a connection, and we want them made like this every time. And so we've never had a failure with one of those connections. But back in the halogen days, when we were talking about massive loads, when we were putting in 1200 watt transformers and we were pulling, 20 amps on a wire, we used Buchanan crimps and DVRs for all of our connections back then, because the last thing I wanted was to even take the chance that something might even begin to, because you can get a lot of sparks when you're pulling a big load.
Sure.
So we were really, but when LED came around, we started using those dry-con connectors, and that we haven't had a failure. So we're happy with those.
Right. The butt splice connectors that you're talking about, they're like the Lighting Shrimp Corporation, I think.
Mm-hmm. Yes.
That when you heat the shrink wrap, it's just not standard shrink wrap. They have a sealant in between a couple of layers that actually oozes out and seals around the ends. Those are the ones you're talking about, right?
Exactly. Yeah. So it actually seals it all the way around and all the way through the connection. So it's impenetrable. Now we use those for all of our downlighting, and we use those anytime we're doing a connection that's going to be constantly wet.
Right. Do they hold up well if they're not buried, if they're just like on top of the soil or on the tree? I mean, are they susceptible to ultraviolet light?
We haven't had any problems with them. And like I said, we use them for all of our downlights. I think most of them are UV protected. So we haven't had that problem. Of course, we never lay our connections on the ground. But our tree connections, we've never had a failure on one of those. So, and we check them constantly and make sure everything's good. So
now, the Buchanan connectors you're talking about, is that the one with the Allen wrench?
No, Buchanan crimp is in the NEC. Actually, it's the only kind of connection you can use if you're connecting like copper and aluminum together. Like in the old aluminum wired homes, sometimes you could put a copper pigtail on it.
Right.
But the only way you could do that is if you use this Buchanan crimp, which is just a little copper cap, basically. And it uses a crimping device that crimps from like 4 different sides.
Okay.
You know the one I'm talking about now?
Absolutely.
It makes such a tight connection.
For that little crimping device, right?
Oh, yeah. Yeah, they're expensive. and my guys have lost a few of them over the years. Yeah. But yeah, those are the ones that I'm talking about. Yeah, if you want a connection that's never going to fail, you can make that connection and pull a truck with it. It's not going anywhere.
So do you twist those, or do you like when you put like 3 wires together? Do you twist the wires together? Or you just put the Buchanan crimp on it and give it a squeeze?
Yeah, I never. You don't have to twist them. I always give them just like a half twist,
right?
Just to do it, and then put the cap on there, and then crimp it, and it's never going to fail.
Right. Okay.
And then put that in a grease tube, and
you're good.
There you go. You're good to go.
So we're about out of time here. We've talked a lot more than I thought, but you get a couple of old guys like us talking. But is there anything else that you have to say about landscape lighting in general, or problem solving, or anything like that?
Really, the thing is that I would say, pay attention to the basics. As long as people really pay attention to the basics and understand that every one of those is super important, they'll be fine. Design is going to be different for everybody. Every designer is going to see things differently, but take the time to try things. Think outside the box. I use some fixtures for things that you would never even imagine. Sure. But it's like, hey, I know what kind of effect I can get out of this fixture or this lamp, because a lot of times, here's a big one. Don't overdo it. Don't overlight, you don't need, 1,000 lumens to light up a crepe myrtle. Okay. It's just not necessary. Right. But I see that all the time. Yeah. And so just, take it easy.
Right. But if they want to learn a lot about landscape lighting and do it in a brief way, they can go to Amazon, pick up your book. You have it on Kindle. You can download it on your iPad. You can get the old-fashioned hardback copy and read up on it. I think it's a great little book for the basics and probably beyond basics, to tell you the truth. And the name of the book again is what, Paul?
The Landscape Lighting Guide, a Contractors Resource. Can I say one more thing?
Sure.
Look into the Association of Outdoor Lighting Professionals, the AOLP, for anybody out there who's interested in lighting. That's where you and I met. But that's a great organization for the outdoor lighting industry. So look at that too.
And if you're an individual looking to hire somebody, it's always good to hire somebody with an AOLP backing, that's gone through the classes, that's learned how to put things together correctly and all of that. And that always helps. You can't go wrong versus, some of these guys that, started their company yesterday. So anyway, with that, Paul, I want to thank you very much for coming on the Light It Up podcast. We've kind of hit on the surface of landscape lighting. Hope to have you back on here soon. And with that, stay safe, stay out of the bad weather. Talk to you soon.
Thank you, Tom. Appreciate it. Take care.